Let's pause for A. What do you read this as? If it says, must there be a place where F equals, then you should think IVT. What are the conditions for IVT? Conditions are continuous, that's all. And I guess between this has to be satisfied for it to be applicable. So, did you start by saying continuous, or did you say it later? When did you say it? You needed to say it something. Did you just start by saying H is continuous? H is continuous. You don't really have to get into why you say that, although I guess if you wanted to, you could say because G is continuous and F is continuous, H is continuous, but you don't have to get into that level of detail. They cut you a little bit of slack. What about the H of -5? Don't we first have to work with the endpoints? H at 1 is, what'd you get for H at 1? 3, and what'd you get for H at 3? -7. So you would need to say somewhere in your proof about betweenness. Did you say it now? -5 is between? Or did you say it in your conclusion? Read me your conclusion, please. Did you say something like H is continuous and -5 is between H at 3, which is -7, and H at 1, which is 3. So by IVT, something like that. I don't know how you were taught to phrase this. Will you talk to me here? Is this about what you did? There is an R where H of R is -5. Is that about good? Okay. They would look for continuity, they would look for establishing the endpoints, and the point they ask about is between, and then some kind of reference to IVT. All right, go to the next one. When you're done with me, feel free to move on. We'll go over B in a minute. listos? ¿Sí, Brandon, estamos listos? ¿En español, por favor? Más o menos. This means there must be a place where the derivative is -5. What is this reference to? If they say, must there be a place where the derivative is something, you should think MVT. All right. So what are the conditions for MVT? Conditions continuous and differentiable. Now technically it's continuous on the open, on the closed, and differentiable on the open. But on the AP they don't get that picky. That said, good math is good math. So if you go that detail, that's fine. I said something like H is continuous on 1 to 3 and differentiable on 1 to 3. Do they actually tell you that? Am I just assuming that? I hope I'm. Yeah. Okay, so F and G are differentiable, so H, the composition function, is differentiable. So by MVT, here's where I go slightly different. I kind of get into their question here, rephrase their question back at them. Does there have to be a C, blah, 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 blah. So by MVT, there is a C in 1 to 3 such that, and then I hope and pray that this actually works out. By the MVT, what is it? H prime at C equals the instantaneous rate of change equals the average rate of change. So you should be showing some MVT actual work. If you just said, yeah, there's an H prime at C equal -5, without showing that you actually know the mean value theorem is this idea, that's not going to cut it. You need to say it's equal to this. What is H at 3? I think we just found it was -7, right? And this was 3 over 2. That does indeed equal -5. All right? So that was MVT. Cool? All right. Try C, which is fundamental theorem of calculus part 2. Yeah. There you go. W prime at 3, what is it? F of G of 3, or actually if you did this generically first, all the better. F of G of X, but then times G prime of X. We chain rule, oops, yeah, okay, are you with me? Or if you like here. So F at, what is G at 3? I don't have the table in front of me, help me out here. 4, what's G prime at 3? 2, what is F at 4? -1, so as you get -2 for an answer. Boom. Okay. If you didn't remember the chain rule or you didn't quite know what to work it out, it's the idea that the derivative of the antiderivative are inverses, but then there's also this chain rule component to it. All right, last but not least, first of all, I have a couple typos in this, so I want to make sure that you understand. There are 3 existence theorems. Must there be a y value such that equals this? Must there be a derivative such that equals that? And there's also, must there be a y value greater than or equal to all the other y values? This, in plain old English, y value greater than all other y values. What do you take that to mean? Max, yeah, it's absolute max. when you see some kind of phrasing that says, does there have to be a y value greater than all other y values? That's an EVT. The third existence theorem is the EVT. Now, we actually think of the EVT on two parts. Yeah, we always use the absolute max has to be an endpoint or a critical limit. But the first part of it says, if a function is continuous on a closed interval, an absolute max and min must exist. And this should actually read greater than or equal to or less than or equal to all others. Okay, so on this, must there be a place, now notice it says F, not H, so don't go talking about H anymore, it says just F. Must there be a place where F at that value is greater than or equal to all other values? Well, the conditions must be met, just like all theorems. F is continuous on a closed interval. They give you a closed interval. Notice they're saying a closed interval, 1 to 4. Okay? You with me on why it has to be continuous on a closed interval? If I had a cube without a closed interval, does it have to have an absolute max? No, only by closing it off does it have to have an absolute max. Furthermore, obviously, even if you had endpoints, but it failed to be continuous, that also wouldn't have an absolute max and min. But if you put those two things together, continuous, closed interval, it has to have a greatest and least y value. So, back to this. F is continuous on a closed interval. So, by EVT, here's where you could either say it just like they say it, there must be a K, blah, 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 or you could say there must be an absolute maximum. Either way. You follow me? Okay. Questions on that free response? This is actually, I'm going to throw this question again at you, but that question you just did there, it's actually one of the most famous AP calculus questions because it has the lowest averages of any AP calculus free response on record. The average is the only question to have an average less than 1 out of 9. It was 0.9. Part D has changed. I changed part D. That EVT question was actually an inverse derivative question. But we haven't done inverses yet, so that's why I changed it. That said, it's a good one, and I might just give it to you again someday and see if you learn from it. Would you write yourself a note here? If it's multiple choice, then you do not have to show conditions. Don't have to show MVT conditions. You can just do the calculation part, all right? That should get you pretty well started on this. This is mostly mean value theorem, but it's also some volume action in there. It's what I would consider a fun sheet with staples. It is not a packet. In my mind, a packet is 3 or more papers. It's a fun sheet with staples. All right. Isn't fun sheet just way better than worksheet? Who wants to do worksheet? Am I right? When you do tonight, you go, I have a fun sheet. All right. Questions on set 85. Questions on set 85. 3, 2. 19. Yeah, 5. 5 you could do 2 ways. 20. Well, you know. All right, first of all, there's this crazy Saxon vocabulary. It gives you this function, I think it's sine plus cosine. A closed interval. He uses a whack name for it. He says use the critical number theorem. That's a big no. We use what's called the EVT in every other textbook in the world. It's called the extreme value theorem. Okay? which is to say that you're supposed to find absolute extrema because you have a continuous function on a closed interval. It must have an absolute max and min, and they must happen at endpoints or critical numbers. All right, so I think later on he also asks you to find the inflection points, which is something else we'll get to. You with me? I assume was the hard part, what do you mean by the critical number theorem, or shall we continue? This question is 3. Shall I continue, or just all of it? If you just write it down for me, and I'll copy it on my paper for you to put on here. Is that what I'm saying? So, absolute max and endpoints are critical numbers. What's the derivative? I'll let you hit that. Surely that's doable. Whose question is this? Thank you. All right. Excellent. This is 0 and defined where cosine is sine. And I think we know that there are possible pi over 4s, but the sign, S-I-G-N, has to be correct. So where do these two come out? The same and the same sign. Pi over 4 and I guess 5 pi over 4, but that falls out of the region. So we're just going to go pi over 4 is our only critical number. Do you agree? All right. Then, do I do a sign test to show the derivative is going negative to positive, or is it more of a find f at the candidates and compare? Yeah, it's more of a find f at the candidates and compare their values to see which is the greatest and least. The only place the absolute max and min can come from are these 3 candidates, so I just have to let them fight it out. F at 0 is 0. Nope, it's 1. F at pi is negative 1. And f at pi over 4 is root 2 over 2 plus root 2 over 2, which is just root 2. From this, we can conclude the absolute max. Do they want where the absolute max is or what? The values. Okay. So the absolute max value is, which is bigger, 1 or root 2? Is root 2, because root 2 is greater than the other guys. And the absolute min is negative 1 because it's the least f. Negative 1 is less than. Okay, and then the inflection point question. That's where the second derivative changes sign, yeah? So the second derivative is negative sine minus cosine. That would equal 0 where sine and cosine have the same value opposite signs, which is at 3 pi over 4. And I feel like that is a sign changing place, although I could verify it with a sign test. Well, I think we're good to go there. So then do they say the coordinates or just the x? Just the x, okay. So f has an inflection point at 3 pi over 4 because f double changes. All right, not equal 0, changes sign. Okay, cool. 3, are we good? 2. All righty. So they say this is the picture, and it helps to look carefully at the picture. Would bet if you're having trouble with this, you did not look at the picture hard. They are giving you dV dt is positive 1 something or other cubic inch per second, and they're giving you the radius is 14 inches, and they want dH dt when the water's halfway up. So I guess that means when a height is 7. You follow? All right. They also, it would have been a way better problem if they made you develop the equation of this by volumes of revolution instead of just handing it to you. But IRH squared minus 1/3 pi h cubed Okay, cool. So, what shall I do? Shall I differentiate with respect to time straight up now? Okay, there's actually an easier thing to do that makes your life easier, and that is to recognize what R is. R is 14. It's always 14? Yep. R represents the radius of the bowl, not the water surface. Okay, so if you're thinking, oh, this is a variable with respect to two different, no, R is constant. R is always 14, always. Now that said, if you did all the calculus, you could still get there, but what's the RDT later? It's 0 because it's still not changing. Much easier if you just right away say this is 14 pi h squared minus pi over 3 h cubed, and you put in the constant r. Then it's just differentiating with respect to time. 28 pi h squared dh dt minus pi h squared. That's h, not h squared. Sorry. 28 pi h dh dt minus pi h squared dh dt. I think you probably see it from there. Solve for dh dt. Do you want to substitute in now, then solve, or solve, then substitute that? Anyway, you see it from there, right? Substitute, solve, or solve and substitute. Okay, 19. Question on 19. Is 19, whoever, is that person still awake? Hey, 19. Okay, this is a good one. You don't have a quiz or a test this week, but I would think maybe I'll quiz this week just to say, are you on top of your homework? So it is meant to be just a reward for if you've been doing the homework well and you've learned from the hard ones, then you should be good. But if you've just been doing a lame job in the homework, then it should penalize you for that. This is the idea, and they're cutting it off at 3. So they're taking this region and revolving it around the x-axis or the y-axis? X, okay. So if you take that region and revolve it around the x-axis, think of, first of all, if it's around the x-axis, are we going to use x or y? X, at least until Wednesday, and then we're going to use y. All right? And because there's a gap between the area and the region of axis of revolution, there's a washer being made, yay? So we say something like the sum of many pi big R squareds minus little r squareds, and because it's around x, we use x. So what is big R? Big R is the distance from the axis of revolution to the outer point of the picture. And the outer point is points on the parabola. Little r is from the axis of revolution to the inner circle. And the inner circle ends at the line. And the limits of integration are from 0 to 3. I don't know if it says this calculator or not calculator. Doesn't say. So either way, we're good. Okay. You with me on that? Does that get you started? Yeah. Cool. 5. Is 5 still a question? Yeah. Okay. First of all, do you remember what that notation indicates? Greatest integer function. Okay. This used to be used a lot in computer programming, especially if you had something that couldn't be partial. For example, if I made a program that said, hey, based on this many students, this is how many buses. You obviously couldn't have 0.23 of a bus. You would have to round up or down accordingly. So when you can't have part of something, you'd often use a greatest integer function to make your program work and only give whole. In this case, the most basic greatest integer function, remember, is just numbers less than or equal to whatever you, let me say this again, right? what comes out is the greatest integer, less than or equal to what you put in. So for example, if I put in 0, what's the greatest integer less than or equal to 0? 0. If I put in a half, what's the greatest integer less than or equal to a half? 0. It would stay 0 until I got to 0.99999. It would still be 0, but when I put in 1, the greatest integer less than or equal to 1 is 1. So it is an open circle on the right. Rather than memorize that, I would prefer you understand that. And that's true for all bars. Now, I would actually, in this case, normally when I say prove it's not differentiable, it's almost always a alternate definition case. But there is another way I can envision that's mathematically sound. What's another reason you could prove, or way you could prove this is not differentiable? 0. Yeah, if you prove it's not continuous, then you can say, therefore, it cannot be. That's a theorem. If a function is not continuous, then it's not differentiable. So if you just prove not continuous, prove, not stated, prove, then that would be sufficient. So for example, if you said the limit as x goes to 0 from the left is, from the left is -1, and the limit as x goes to 0 from the right is 0, you could say because -1 is not equal to 0, f is not continuous at x equals 0, therefore it is not differentiable. Okay, that would be sufficient. If you would like to see that, hey, how would it look if you'd used the alternate definition? I can do it that way. This is okay. 20, question on 20. All right. 20 is a replacement. Good call. I forgot to give you the answer to this. So, I would suggest to start by factoring. Oh, this one is wacky. Oh, no, it's not wacky. Oh, it is wacky. All right, so this is plus, this is plus, this is plus. So there's a couple different yuckies to this. The most confusing or weird kind of, I've never seen that before, is at -1, is it a whole or an asymptote? It's an asymptote, okay? I know this is a common factor, but even after removing it, you still have an issue at -1. So it is an asymptote. If you were to think, let me get into the details of what's really going on there. As I got closer and closer to -1, these would constantly go away, but you also have that asymptote behavior. Oh, dividing by really, really small gives me big. So the whole never happens, and it's more like a asymptote there. All right, and then as far as the other end behavior, do we have a horizontal or a slant? Slant. Do I need to divide out the top one, or can I remove the x plus 1 and divide out this one? Or would they both work and they would both give this? They would both work. Which one do you prefer? The bottom one. Synthetic or long? Synthetic. All right, so x squared minus 3x and no constant. So 1, 4, 4, 4. I feel like this is y equals x minus 4 is the slant. Yeah? 1, 2, 4, which means that probably looks like. All right, so my bones, my skeleton of my graph looks like this. And let's go far left. Far left part of the graph does what? Is it up here or down here or the ultimately really, really clueless? The both. Yeah, let's just say it's definitely not both, okay? Which one is it? It is the below. It really has to be below. You could also look at the remainder and that would help you interpret, but it is below. It doesn't have any roots, it can't turn up, it just has to be below. There is a sign change around 1 by virtue of there being a first degree term here. So we will change signs there, and then change sign again at x, and then head out, something like that. And the whole that I would have normally expected never happened, and so that's what we got here. Cool? Okay. Anything else? Sure. Evaluate FG. First thing you need to wade through is that when it says this, is that product or chain rule? Is that F of G of 1 or F times G? F times oops. Time. Okay, so it's product rule. F at 1, G prime at 1, G at 1, F prime at 1. Do your stuff. Okay? All right. Let me know if there's anything else. Feel free to work together. Whatever you're going to learn best with. If it helps you most to do it on your own, do this. Handwriting on your homework that says, hey, jump is strong, and you should look at it. Those are the problems that you need to mental note the quiz over. Well, checks are good, that usually means you're looking good. Tram, you're not here, right? So try that. Are you missing it? Alright. Yes, sir. Yes, you may.
I like your Crocs this year.
Thanks. It might come as a shock, but they're actually my daughter's. Yes, sir. So, this is actually, I don't know what Yes. So, we can see. That's where it's headed, unfortunately. So, okay, so this is the last concept. You look at the IBC rate, 40 to 60, two's not in here, so it feels like I know. But besides looking at velocity and the table of velocity, also consider so empathy would mean that if you think of Q as the derivative of position, then you can also think, is this a question about mechanically or and so think in NDT
My AMA reader would be so interested.
if you feel like I would first give it the change in position in 40 years. So the average velocity, the average change in position, 2 meters per second, like 20 over 2. So yes, but it's not V is, if you use IVT, so you're looking at it as instead of saying V and IVT, you're saying a con and IVT. So you need to
Even after square root. Just square root it and then take the derivative. No, you just take the derivative.
I don't think it's girly. I'm scared. You should have one where the curve is positive, so you just use Come on now. Thank you. Have a great day, people.
You're completely wrong in every basis of your.
Oh.
Hang on. Because there's time in
These are so sticky. Everywhere I walk, it's on the front.
I want to talk about
Yeah, what do you think?
I think I need to do it just from what my mom said.
Yeah, I just, yeah, I mean, we can talk about it. I mean, you're my dog. I think it's
And my brother ended up in anyways.
yeah, so yeah, I think he's just sweet. I mean, and there'll be a lot of communication killed. I mean, personal should be seen. It'll be good. Okay, so I will take care of it. I'll talk to the counselor. Who's the counselor? Okay, I will take care of it. And
such a wrong idea about why.
what's your fifth? What is your second verse?
I have Spanish and
So we'll try and work it in such a way that we can have the solution.
I know Mr. Walton is just fifth and sixth grade.
Oh, cool.
So
So
I
class
think
is yours, so you can just straight up
So I
switch.
can switch.
Oh, that'd be great. Okay, so it'll only be two classes and the same teacher, so it'd be great. Okay, I will email the counselor right now, and I assume it'll go through today, and you should start the new schedule tomorrow.
Wait, I haven't started it this semester.
Oh, you want to, I don't know. Do you want to start it now or next month? You can,
I don't know. Should I start it? What would happen to my grade?
for this class, or for
I
my
guess
math class?
for math.
It would start from now, basically. It would start from 0.
Do I have to take it?
No, I would give you, I would, no, I would just grade you based on the next 4 or 5 classes. I would probably have them come in and set up just to see what they've done, so you can see the tests that I've given them.
So I
It
can,
would count.
okay, so I can just switch to sixth and then third hour.
Right.
Okay.
6th and 3rd, yes. It would be,
Okay.
and assuming if your English class is the same, then all the grades should come through.
Yeah.
And except for him, because I think manually you need to change over all grades, but it is what it is. So that's what you want to do? I mean, it's best to do it now.
Okay.
Okay.
So, okay, perfect.
So, I will, yeah, I will tell him now, and I don't know if he's able to change it now or change it tomorrow, but I did it. Okay.
Congratulations!
That's
Positive
really-
reinforcement.
Thank you. Could I ask you a question?
Sure.
So I have a student that's going to change it 6 weeks now. I mean, do they?
And then move down.
Yeah, to AD. But the other classes are straight up switch same teacher. The English should be the same teacher, just in different period.
Okay.
So, should she start that next week tomorrow, or?
Let's see.
Huh?
Yeah,
I was just about, I just got, so I was just about to email, John now.
So why don't you carbon copy me on it? And yeah, I mean, if she would start that tomorrow, you probably want to run it by the English teacher,
Yeah.
just to make sure.
Yeah. Yeah, yes, basically, yeah, if he has any questions, he's a new guy, so that's, he's an old English, Mr. Wolf,
Oh, I see.
so that's the only, this one, or the one. Yeah, so, should she talk to Mr. Wolf also, do you want me to copy him in on the email? I usually just call the council.
I struggle with that. Helps both if they fill out, but that would help.
Okay, I'll just copy him.
So should I still go to
Yeah, just tell him, oh, what?
Make this work.
To what?
Maybe October, which means your schedule will actually change a lot. You can't actually take like 10 days.
You're gonna do this, you're gonna switch things up tomorrow. You don't wanna actually show up on the roll.
So I can come to
You come here quicker.
Okay.
Before you just.
Okay.
Does he have, he said he has numbers?
Yeah, I think that's.
I hope his numbers are.
So they'll have it.
It'll be, yes, they'll be expecting. And I will, I'll tell you what, don't worry about this. Yeah, he'll just.
Okay, I'll
Tell him I'll be there.
Okay.
Give me a pass.
No, I'm in St. Louis.
Okay, alright. You're welcome. How do I what?
How did you change this name?
I changed everything. I like
It was just funny, cause like.
you haven't switched your room up?
No.
You don't?
No.
I changed your room all the time.
Like you moved your dresser?
Yeah, man.
I have a bunk bed that's connected to the wall and I share a room with my sister.
So I guess you won't be moving these things, it's connected to the wall. You could put your,
That would, I agree.
you could put your, yeah, you could, or you could put your dresser on its ear, or something, or backwards. Just do something different. It needs to change, you know, you gotta change.
I haven't changed in years.
Really? They say variety is the spice of life.
Well, I don't